Hey everyone, in this series of video, we're going to go over simple regression. Now, before we get into that, let's review correlation. And the reason we're doing that is because really simple regression is correlation on steroids. And so it's a good idea to remember key concepts about correlation. So let's start with this. What kind of research questions do we use correlation analysis for? Well, if you recall, we used those for association research questions. It's whenever we want to know if there is some kind of association between variables. And when it came to correlation analysis, we needed to pay attention to the level of measurement of the variable because that would determine what type of analysis to use. We would use something if it was nominal data versus if it was interval or ratio. And when it comes to simple regression, we will concentrate on the Pearson correlation coefficient. So we will be working with interval or ratio levels of measurement. Next review question. What does it mean when two variables have a negative relationship? Well, that means that when one variable goes up, the other one goes down. So a good example would be temperature and hot cocoa consumption. As the temperature goes up, the consumption of hot cocoa goes down. So whenever you see that kind of relationship where, as I put here, when one variable goes up, the other one goes down, that's a negative relationship. Okay, so that's correlation review. Now let's go back even further to our middle school or junior high math to set the stage for getting into simple regression. So let's go through this real quick. Here's a standard shipping graph, and on the x-axis we have the package weight, and then the y-axis would be how much it costs. So looking at this graph, a 2-pound package costs how much to ship? Well, if you look at 2 and then the line, we see that it costs $4, right? There we go. Now, what about a 3-pound package? Well, we go look at 3, go to the line, and we see that it's $6. Each increase of 1 pound in weight is associated with an increase of what in shipping cost? Well, it looks like for every dollar, or not dollar, for every 1 pound in weight, it goes up by $2 in shipping cost. And this $2 change in this particular case, that's the slope of the line. So the slope of the line equals 2. So that's this graph. Now, what about in this hypothetical graph, the next one, express shipping costs? Well, we would expect this to cost a little more than standard shipping. And so looking at the graph again, a 2-pound package costs how much to ship? Well, let's see, so $6. What about a 3-pound package? Well, that is $9. Each increase of 1 pound in weight is associated with an increase of how much in shipping cost? Well, for every 1 pound, it looks like it increases by 3. And so we could say that this is the slope of the line. So in review, the slope of a line tells us how much change occurs in y when we have 1 unit of change in x. So that's really important to remember. The slope tells us how much change occurs in y for every 1 unit of change in x. And so that concludes our junior high review. So let's go back to statistics. Simple regression is another way to look at correlation. One variable is chosen to be the dependent variable, the other is the independent or predictor variable. And as I mentioned a minute ago, it requires interval or ratio measurement on both variables. And we can use regression for 2 purposes. It's to examine the association between variables. And then here's a new one that we didn't talk about with correlation. We can build a quote prediction model. And the reason there's a quote on there is that, yeah, it predicts a value based on what your dependent variable or independent variable is, but it doesn't predict the future. So that's an important distinction to remember there. Now let's do an example. Advertising expenditures and store traffic in yarn shops. Now this might look familiar because in our correlation lesson, this was one of those examples that I had you go through on your own. Now we're going to look at it again in this video. The research question is, are advertising expenditures on Friday associated with store traffic on Saturday? To find out, store traffic was measured on a Saturday in March in 20 randomly chosen stores in the chain. Advertising expenditures for the day before were also tabulated for these stores. So based on that data gathered, we put that in a scatter plot. So each dot you see there represents the 20 stores. So for example, this dot right here, they spent around 290, let's say, in advertising, and that resulted in around 145 in traffic, something like that. So yeah, each dot there represents a store. And in this case, so this is really important here, and actually let me type that here, important, the exclamation. The independent variable goes on the x-axis and the dependent variable on the y-axis. All right, so with that background information and with this information, in the next video, let's put a regression line here.